Okay, question number 3. This is a t-test. What are the t and p values of an independent t-test used on the following null hypothesis, right? And the hypothesis, there is no difference in the mean ages of second-class passengers who did and did not survive. Okay, so basically, I want to divide my my data into two groups, two tables. I want them to have one table has only second-class passengers that did survive, another table that has only second-class passengers that did not survive, and I'm going to compare the age columns in each of those tables using a t-test and get a p-value and see if it corresponds to any of these. The kicker here is I've got this last potential solution which says the data in one or more of the samples is not normally distributed and it is not appropriate to use to apply a parametric test. Remember, for a t-test, your data needs to be distributed normally. So even if you do a p-test and you can decide whether to accept or reject a hypothesis, it might not be valid because the data might not be normal. So you need to test whether the data in each of those columns is normal first before applying the p-test. If at any point it's not normal, then you can't do a t-test, which means you're going to select this option here. So be very, very careful in the summative test that you do check. So the way to, right, let's do, first things first, let's get those tables organized, right? So I want a table for the second class who did survive, and then a table for those who did not survive. Okay, so I've already defined a second class data frame, but I'm going to treat it as independent question. So I'm going to create a new variable called second class survived, and I'm going to subset that with respect to my original data frame df, and this time I'm having p class equals 2, just as above, and this time, and it's an and survived equals 1, and then I want another table, second class died, okay? And survived equals 0 this time. Okay, double equal sign, remember that, control and enter. Did I control and enter that one? No. Okay, so I've got those two tables, and you can go and take a look at them once you've got them. Now I'm going to perform a t-test, but first I'm going to perform a Shapiro test, okay? A Shapiro-Wilk test, I should say. And what this is going to do is going to give me a p-value, and if that p-value is less than 0.1, it means my data is statistically normally distributed, which means I can use it in a t-test, okay? If you ever get stuck, I can't remember what the value is, you can run it there, help Shapiro test, and there it is, p-value less than 0.1. Okay, right, so we're actually going to run the Shapiro test. Let's do it on the second class that survived first. And remember, I'm interested in comparing the ages of those two groups. So I'm going to hit it with a $ and use age. Okay, so for my Shapiro-Wilk, I get a p-value of 0.02, which is less than 0.1, which means my data is normally distributed for that group. How about second class died? There you go. Okay, that one's even lower. That's much lower. So again, that's normally distributed. So I can hit it with a t-test, and this for the t-test, I'm simply going to put both of those columns in from each of those tables. Okay, I get a t-test with a value of 0.0003, a t-value of minus 3.6886. Let's go back and look at it. Okay, so the only real option here is this one. Okay, now because the p-value is less than 0.05, that's your critical value, I know that I can reject that hypothesis. In other words, the difference in the means of the ages between the groups of second-class passengers that did and did not survive is statistically significant. Okay, right, that's that question done. Let's move on.